Okay, so this is 1.6b in college algebra. And the picture I have is the same picture on page 137 that they don't really explain very well, and I'm going to go ahead and do that. Okay, what we have is a graph. This arc right here, nonlinear. We have a secant line, or a line that goes through two parts of the circular graph. Okay? This point right here is over x up y. Over x up y, f of x. That's the distance, that's the function, that's what we went up there. Okay, this point right here is over x, but bigger than that. It's x plus this distance, which is h. So this distance here is x plus h. And my up is the function of that distance, x plus h. So my y value. So there's my x value. There's my y value to name that point, x, y to name that point. Okay, so if I want to find the slope of this line here, what do? Y over x, right? Well, what is my y? My y is f of x plus h, okay? And my slope is really the difference of y over x, I'm sorry. So the difference minus my y value there, all over my x value minus my x value. Okay, so that's my formula. And again, you will use this in calculus. You would get this exact same formula and be expected to be able to use it. Now, they'll teach it to you again, but when you see it, you'll be like, oh my gosh, I remember this. This is not simplified, though, because I have an x there and a negative x there. So this simplified looks like this. So the slope is that. Okay? So far, not so hard. All right, so for the function f of x, and this is called the difference quotient. Okay, you don't have to understand what it is at this point. It's just called the difference quotient, and it's actually the slope. All right, so f of x equals 9x plus 5. And if they're asking for the difference quotient of that, or you could even say the slope for that, what they're going to do is you're going to find different parts of this equation, one piece at a time, and then we'll have the equation put together and then we'll simplify it. So one piece at a time, we're going to look and find f of x plus h. So f of x plus h. Okay, what that means is whenever we see an x, we're going to put x plus h in its place, just like we have been doing. So all this means is that goes in place of the x. Okay, then we have f of x, which we already know f of x, it's this. And the next thing we have is the h. Okay, so let's write that out in its entirety. F of x plus h is going to be 9 times x plus h plus 5. Okay, so that's my f of x plus h. That's this first part here, minus f of x. Where's my f of x? Right there. Minus, make sure you put it in parentheses, over h. Alright, now I'm going to do the math. So let's move a bunch of this stuff up here. Move all this over here. And I get 9x plus 9h plus 5 minus 9x minus 5 all over h. Alright, what happens here? This and this cancel, this and this cancel. and I'm left with 9h over h. Those cancel, so I'm left with 9. That's my difference quotient. That's the average rate of change. That is the slope. Okay, so that's what they're doing when they're doing difference quotients. So let's go to example 4 and try another one. So here's example number 4. They give you the function, they give you the formula, which we just put on there a little bit ago. Now we're going to look at each one of these. We're going to find, first of all, and all that means is whenever we see a variable, we're going to put x plus h in its place. Okay? F of x, so we already know it's the original problem. And then h is just going to be h. So let's go ahead and write this here in its fullness. Alright, so we have minus this over, h. Okay, so let's write this whole thing out. 2 times x plus h times x plus h gives me, I'll make braces here, x squared plus 2xh, again I'm using the FOIL method, okay, minus x minus h, took the parentheses off, have to change the sign, minus 2x squared plus x, again change the sign, all over h. Okay, now let's distribute that. Notice how these get a little bit long. Alright, so I've got a 2x squared here and a negative 2x squared there, so those go away. Let's see, do I have anything else that's going to go away? Let me slide all this up a little bit. I have a 4xh that doesn't change. That's going to stay the same. So now we've used that. The 2h squared, nothing happens to it. We can't combine that with anything. And let's see, I've got a negative x and a positive x, so those cancel out. I've got a negative 3 and a positive 3, those cancel out, so that leaves me with just a negative h over h. Now what I can see here is my top number, I can factor an h out. And then I can cancel. Notice when I factored this h out, there's always a 1, it doesn't just go away. So that means my difference quotient is 4x minus 2h minus 1. And I'm done. Okay? So that's the difference quotient. Now we're going to jump into the composition of functions. Composition of functions you have used before. It looks like this with an open circle G. F composition G. Okay? And what that means is, in fact, I like to write it this way because it makes more sense to me. It's the same as f of g of x. So it means you find g of x, take that answer, and plug it in there. So let's just do an example here so you can see what's going on. Alright, example 5. We have f of x, and that equals 2x minus 5. We have g of x, which equals x squared minus 3x plus 8. And it says find each of the following. Okay, so what they want us to do is find f composite g of x. So what that means is, I'm going to write this again, f of g of x. So we're going to start here, and we're going to write f of, well, what is g of x? G of x is this right here, right? Okay, and what does this mean? This means when I take my f of x function right here, whenever I see the variable, I'm going to put this whole thing in its place. Okay, so let's do this in blue. So I'm going to get, for this right here, 2 times my x value minus 5. Then I'm going to distribute. Combine like terms, and I'm going to be done. Now if I were to do g composite f of x, it's going to be the exact same thing, only I'm going to do the f of x first, and then I'm going to put the g in. Alright, so let's go ahead and look at one where we've actually got some numbers here. I'm going to leave that one there just like that, and we're going to do B as in boy. We've got f composite g of 7. Alright, so again, I'm going to put our original problem up there. Okay, and this can be written then as f of g of 7. So what's that mean? We're going to put 7 in the g of x. And we're going to get 49 minus 21 plus 8, which that one is going to equal. It's going to equal 36. So now that is the number I am going to put in for here. G of 7 is 36. So I'm going to put f of 36 in there. So now I'm going to take my original problem, this one right here, okay, and I'm going to get, let's see, 72, 67. So that is my final answer for f composite g. This was only used to help me. That was the first step. Then I plug it in here and I get my final answer right there. Now let's do g composite f of 7. So now I'm going to look at f of 7. I'm going to put 7 here. So 2 times 7 minus 5. So f of 7 is going to equal 9. So if, I forgot to put this on here, g of f of 7. Okay, so if f of 7 is 9, I'm going to replace that with 9. So this means I'm looking for this, because f of 7 is 9. I just found it right here. So now, whenever I look at this equation, I'm going to put 9 in its place. So g of 9 is going to equal 9 squared minus 3 times 9 plus 8, which is 81 minus 27 plus 8. And that answer is going to be 62. Okay? Alright, I'm going to stop this video and we'll go to example 6.